Hello everyone. In this class, we are going to learn some important formula related to indefinite integral. These formulas are very important and all formula we will derive from derivative. So, as we know, integration is the inverse process of differentiation. So that we will apply here. Main concept of this topic is if derivative of phi x is fx, then integral of fx with respect to x is phi x plus c, where c is the constant of integration. For example, these all things we have learned in first class of this topic, like x cube by 3. Derivative of this is x square. So integral of x square with respect to x we represent in this way, and its value will be x cube by 3 plus c, constant of integration. So we are going to apply this concept to find several formula for integral. So first of all, see the formula number 1, x to the power n plus 1 by n plus 1, derivative of this. Here n is not equal to minus 1, because when n becomes minus 1, then denominator becomes 0. So it should not be. In that case, if we differentiate this function, we will get here x to the power n. So we got one formula. Integral of x to the power n with respect to x is this. So here write down x to the power n dx is n plus 1 by n plus 1 plus c. This we can apply in some questions, like x to the power 3 by 2. Integral of x to the power 3 by 2, x to the power 3 by 2 plus 1 by 3 by 2 plus 1. So here 3 by 2 plus 1 is 5 by 2. So 2 by 5 and x to the power 5 by 2 and plus constant of integration. Now root x, integral of root x x to the power 1 by 2 dx. So directly we can write the answer here 3 by 2. So 2 by 3 and x to the power 3 by 2 plus c. So this is very important formula. We can apply this to find the integral of variable x having exponent other than minus 1. Next formula is log x. So derivative of log x we know very well. Derivative of log x is here 1 by x. So integral of 1 by x will be log x plus c. We put modular sign in this x because x cannot be negative. So third formula, e to the power x, derivative of this is same, e to the power x. So integral of e to the power x is also same, that is e to the power x plus some constant c. Now next question, next formula, a to the power x by log a. So derivative of this, you know, derivative log a is constant, so keep it as it is, log a, 1 by log a, and derivative of a to the power x, you know, a to the power x into log a. So this will cancel, this is equal to a to the power x. So I have written here a to the power x by log a, so that this should come in standard form, so that we can get the formula for integral in standard form. So a to the power x dx is a to the power x by log a plus c. So in derivative, a to the power x, derivative of a to the power x is a to the power x into log a. In integral, a to the power x by log a. It means in derivative we multiply by log a, and in integral we divide by log a. Now fifth one, sin x, derivative of sin x, cos x. So integral of cos x will be sin x and some constant c. 6, derivative of cos x is minus sin x. So here we will write derivative of minus cos x, so that right hand side we get standard form. Derivative of minus cos x is sin x. So integral of sin x is minus cos x plus c. In some more formula we can get from derivative. Now derivative of 10x, derivative of 10x with respect to x is sec square x. So integral of sec square x, sec square x will be 10x plus c. Next formula, derivative of minus cot x, derivative of minus cot x, derivative of cot x, you know, minus cos x square x. So minus minus becomes plus, so it will be cos x square x. Now integral of cos x square x, cos x square x dx is minus cot x. Some more formula we will enlist here. Ninth. Now derivative of sec x, derivative of sec x is sec x into 10x. So obviously integral of sec x into 10x, sec x 10x is sec x. plus c. Now minus cosec x, derivative of minus cosec x and cosec x into cot x. So integral of cosec x into cot x dx is minus cosec x plus c. So these all formula we know in derivative, and with the help of that we are getting formula for integral. Now derivative of log of sec x, derivative of log sec x, tell me what will be the derivative. You can apply here chain rule. Log x 1 by x, that means 1 by sec x, into derivative of sec x into tan x. So ultimately we are getting tan x after cancellation this. So integral of tan x, with respect to x is log of sec x. We put here modulus sign. Next one, log of sin x. Find its derivative. What is the derivative of log of sin x? Again we apply here chain rule, 1 by sin x and then derivative of sin x cos x, so is equal to cot x. So integral of cot x, is log of sin x plus c. Now log of sec x plus tan x, derivative of log sec x plus tan x. You find derivative of this. Very simple result you will get here. 1 by sec x plus tan x into derivative of sec x plus tan x. Derivative of sec x is sec x tan x, sec x into tan x, and plus derivative of tan x sec square x, Here we can take sec x common. So sec x common, then sec x plus tan x divided by sec x plus tan x, So this factor will cancel. Ultimately we get sec x. So we can say integral of sec x is with respect to x is log of sec x plus tan x, log of sec x plus tan x plus c. 14th, log of cosec x minus cot x, log of cosec x minus cot x. Derivative of this, again in the similar way, we find 1 by cosec x minus cot x into, again derivative of cosec x minus cosec x cot x, cosec x into cot x and minus derivative of cot x. Derivative of cot x is minus cosec square x. So minus cosec square x. If we simplify this, here it will be plus, so cosec x minus cot x. If we take cosec x common, so cosec x common, then cosec x minus cot x by cosec x minus cot x. You cancel this, the final result you will get cosec x. So integral of cosec x is cosec x with respect to x is log of cosec x, log of cosec x minus cot x plus c. So all the formula we are getting directly from derivative, and it is easy to learn it because formula are derived from derivative. So whenever you forget, you can derive it. So in the first time, I suggest you derive each and every formula, then try to learn. Till 14 we have done. Then 15th, inverse function. Derivative of sine inverse x by a. What is the derivative of sine inverse x by a? 1 by, you can apply here chain rule, 1 by 1 minus x square by a square under root into derivative of x by a, or you can multiply by coefficient of x, then 1 by a. So when you simplify this, you will get a by a square minus x square root under into 1 by a. So it is nothing but a square minus x square under root. So we can get another formula, integral of 1 by a square minus x square under root is sine inverse x by a plus c. Next, cos inverse x by a, cos inverse x by a. Derivative of this is almost same, only minus sign will come here. So minus 1 by a square minus x square under root. So here 1 by minus 1 by a square minus x square root over integral of this function is cos inverse x by a plus c. Now next formula, 1 by a tan inverse x by a. We have multiplied here by 1 by a, so that the right hand side or derivative we get standard form. So what should be the derivative? Derivative of tan inverse x by a is 1 plus x square by a square, and then you multiply by coefficient of x. So coefficient of x is here 1 by a, so 1 by a. When you simplify this, you will get 1 by a square and a square by a square plus x square. So ultimately you are getting a square plus x square. It means integral of a square plus x square with respect to x is tan inverse 1 by a, 1 by a tan inverse x by a plus c. I am going to erase this. Sine, cos, tan. Now cot. So 18th, again 1 by a, cot inverse x by a. Derivative of this is in the similar way. If we differentiate this function, we will get minus sign only here, and a square plus x square. So integral of minus 1 by a square plus x square with respect to x is cot inverse 1 by a, cot inverse x by a plus c. Now 19th, one by a sec inverse x by a, sec inverse x by a. So 1 by a and sec inverse x by a. I am going to change this into cos form, cos inverse, just reciprocal. So a by x, derivative of this. Now we know the formula for cos inverse x by a by x. So 1 by a into minus sign minus 1 by 1 minus a square x square under root into derivative of a by x. So a into 1 by x, so minus 1 by x square. If you simplify this a will cancel and both the minus will become plus. So x by this x, so x square minus a square root under into 1 by x. What we will get here? X into x square minus a square root under. So integral of this is 1 by x into x square minus a square under root with respect to x is 1 by a sec inverse x by a, sec inverse x by a plus c. Last but not least, so 21 by a cosec inverse x by a. In the same way, if we find its derivative, we will get only minus sign and the rest result will be same. So x into x square minus a square root over. So integral of this 1 minus 1 by x square minus a square root under dx is equal to 1 by a and cosec inverse x by a. So these 20 formula we have derived from directly from derivative, and this formula will play a role of basic knowledge. So with the help of this formula we will learn some more formula. So I suggest you all the formula once you derive and learn, then we will be able to solve the question. So from next class onwards we will start exercise. Okay, thank you.